So this is the second video that I am putting in after the insertion sort from our last video. And in this video we're just going to explain about merge sort and how it can actually be implemented in Python. So let me explain how merge sort actually works. It basically works in the principle of the divide and conquer algorithm. It's like we have, as you can see here, with the variable ARR, I have a list that's like 6, 5, 12, 10, 9. It's an unsorted array. And the purpose is to sort this array in ascending order. So let me explain how this actually works. As you can see, in the beginning I have an array like 6, 5, 12, 10, 9, 1. Assume that I have a function, and after the first call what happens is that this array will be split into two arrays. The first array consists of 6, 5 and 12, and the second array consists of 10, 9 and 1. Okay, after the next iteration what happens is that the first array that is 6, 5, 12 is again split into two arrays. So they can be like this, and similarly the 10 and 1 is also split into 2. So what can be there? Like the first array can be of 6 alone, and the second array which consists of both 5 and 12. Likewise, for the 10, 9, 1, you can see that the first element can be 10 and the next array can be of 9 and 1. This splitting further takes place. For the 6 there won't be any kind of splitting because it consists of only one element. Now we move to the second one, that is 5 and 12 is again split into 2. So that is like, what to say, like which consists of 5 and 12. Similarly for this array also, for this 9 and 1 also split into 2, that is like this. You can see here it's split into 9 and 1. So in the end we will be having an array that consists of individual elements, means 6 being one array which consists of 6, and next 5, 12, 9, 1. All these elements will become individual arrays which consist of one element each. So this is the first thing that we have to do. This is what you can call like splitting of the given array. So I believe that you people have understood how the splitting works in the case of merge sort. The first thing is we have to split the array consisting of 6, 5, 12, 10, 9, 1, like being consisting of smaller arrays which consist of smaller number of elements. And finally we will be reaching a place where all the individual elements form an array that consists of individual elements. So let me write the code for that. First of all, let me define a function. Say its name to be split merge. So def split merge. It takes an input of array ARR. Now the first thing is I have to declare a point where this array need to be splitted. As you can see that there is no more splitting takes place after the array consists of only one element, right? So I have to make this function work only if the length of array is what? The length of array is greater than or equal to 1. I have to split the array, right? So in order to split I have to set a split point. That point I can name like mid equals n of array divided by 2. For even number of elements it will be divided exactly. For if it consists of 6 number of elements, the exact middle would be 3. So for 0, 1, 2 will be the first array, and 3, 4, 5 would be the next array. And subsequently for the next case we have seen that there is only one element be present in the first array and 2 elements be present at the next array. Likewise the mid will be dividing. I will be having two halves, right? One left half and one right half. For the left half is like say left half, it's of the array until from the first element to the element just before the mid element. Likewise, I have a right half which consists of elements from the mid element to the last element. Okay, now what's the next thing we have to do? We have to call this split merge recursively until we reach a point where we have individual elements, I mean an array which consists of single element alone. So I'll be calling the split merge. The thing is, I have to give the left half to it, and again I'll be calling the split merge. This time I'm giving right half to this. Okay. In order to see this working, let me print this too. Print left half and print right half. Let me run this and save this too. Let me call this function, say split merge, and give R as the input to this. Okay, what would be the result? Let me run this code. Oh, maximum recursion depth exit while calling a Python object. Here. Oh, we have given that's a small array. We don't have to split it if we have a single element, right? So it should be like if len of array is greater than 1. Yeah, that's fine. Now it should be working. Yeah, as you can see here, as I've told, like the first case it consists of 6, 5 and 12, right? And then 10, 9 and 1. Then the next iteration will be choosing the left half. It is split into 6 and 5, 12, 2 arrays. Then again we won't choose the left half because the left already been consisting of only one element is not working. Now it will move to the right half, that is 5 and 12, which again split into 2 halves, that is 5 and 12. Now once again, like you know that the recursion normally works on the basis of a stack frame, right? So it just comes out to the outer place, like it's again splitting that 10, 9, 1 into 2, that is 10 being 1 and then 9, 1, then finally 9, 1. So in the end you can see that there are different arrays. There is consists of single element, 6 being one array, 5 being another, and then 12, 10, 9, 1 in different arrays. Now what we have to do is we have to merge this array in such a way that the smaller elements of all comes in the first place. So I have to declare 3 pointers. So the pointers to be I equals j equals k equals 0. The HLS to be 0. So let me explain you why have you made use of these pointers. This I will be pointing to the first element of the left half. J will be pointing to the first element of the right half. And what k will be doing is k will be keeping track of the new array that we are just going to make. That's actually the sorted array. The final output be sorted array. So how it's work is I have to make a loop within which I is always less than the length of the left half and j is always less than the length of right half. Okay. Now I have to check that which is smaller element. I mean, if the left half, the ith element of the left half, or is less than the jth element of the right half. And the kth element of array, that here it is the first element of array, will be equal to the smaller element. Here it is left half for sure, left half. Okay. Since we have made use of 2 pointers, the k and I is made use, so I have to increment these pointers like with 1, and I is also incremented by 1. If what could be the else condition? Else the ARR of k will be equal to what? the jth element of right half, right? Yeah. Now I have to increment the 2. The k is also incremented as well as j is also incremented. But remember, there can be a case, and this condition satisfies only if both I and j are less than their corresponding halves. What could be the situation if the both left halves and right halves consist of different number of elements? So that might create a problem. Say if left half consists of more number of elements than the right half, then even after the completion of the right half, left half remains uncompleted. So in order to incorporate an incompleted part of this array in the sorted way to the completed to the final array, we have to write another loop for the left array, right? So that is while I is still less than len of left half, I will add this to the array such that both k and I is increased as in the previous case. And this could also happen for the right half too. So if it happens to the right half, then I'll do it for the right half, the same code we are writing. Okay, then ARR of k equals to right half of j, then k plus equals 1 and j plus equals 1. Okay, now the final thing is, after all these iterations, we will be getting the sorted array, and let me return that array. So I'll be returning the return array. So I think it's done. Okay, split merge. Now I can save the value that obtained from the split merge into a result variable. So I can print the final result. Print. Okay. Now let me run the code. Yeah, as you can see that 1, 5, 6, 9, 10, 12, it's been obtained a sorted way. So this is how merge sort works. Hope you people have understood it. Thank you.